Have you at any point analyzed whether we're truly alone in the universe? Or is there something else to our reality than what we see? Envision, assuming the James Webb Telescope at last uncovers that we live inside a black hole. Join us as we investigate this vital news that will make you question all that you assumed you knew about the universe. So, what precisely are black holes? They're like something out of a frightening bad dream. Sure, you could have seen them in science fiction films, but they are significantly more alarming as a general rule. Black holes are not simply fictitious. They are genuine, as affirmed by specialists. Basically, black holes are huge measures of matter caught into a minuscule locale. Picture a star, ordinarily more gigantic than the Sun, all packed into a circle the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been entranced by black holes for a long time. These objects in space are so monstrous and thick that they can trap light. The most notable speculations about black holes were predicted by Einstein's theory of general relativity. Basically, when a gigantic star reaches the end of its life, it collapses, abandoning a thick center. Assuming that the mass of this center is roughly that of the Sun, gravity overpowers everything, prompting the formation of a black hole. Recognizing black holes is difficult, as they emit no light. Anyway, researchers have found ways to infer their presence by noticing their consequences on adjacent matter. For instance, if a black hole travels through a mass of interstellar matter, it will pull that matter toward it in a cycle called accretion. Furthermore, when an ordinary star gets too close to a black hole, it can be destroyed, emitting X-rays as it does. Black holes also have a tremendous effect on their surroundings. They can consume nearby stars, emit strong gas impacts, and even influence the development of new stars in certain regions, while slowing it down in others. But where do black holes come from? Imagine stars, once gigantic and lively, meeting their disastrous end in a dramatic event known as a supernova. From the remains of these fallen giants, black holes are born. Most black holes start from huge stars that end their lives in a supernova blast. Smaller stars, when they die, transform into neutron stars, which are incredibly dense, but not dense enough to trap light. If a star is several times the mass of our Sun, it implodes under its own gravitational force, forming a black hole. As these collapses happen, something strange occurs near the surface of the black hole. Time itself begins to act strangely. From the perspective of somebody far away, time seems to slow down near the event horizon, the point past which nothing can escape. It's as if the star's clock ticks at a different speed compared to our own. Occasionally, when two smaller black holes collide, they merge to form a much larger and more frightening black hole. If a black hole interacts with a neutron star, it creates a massive nightmare that defies perception. Researchers have struggled to understand the size of these massive phenomena for a long time. Black holes come in two sizes, of all shapes and sizes. Yet here's the twist. Little is relative when it comes to black holes. Extremely large black holes, the remnants of massive stars, can be as large as several times the size of the Sun. There could eventually be up to 10 million to a billion of them in the Milky Way alone. That is a staggering number of black holes that could swallow anything in their way. Anyway, there's something even more immense on the far end of the scale, very large black holes. These can be millions or even billions of times bigger than the Sun, and they exist at the center of huge galaxies, including our own Milky Way. It's like a tremendous dark emptiness pulling everything toward it. Well-known physicist Stephen Hawking spent much of his life studying black holes. His talks were always brilliant, though some of his theories couldn't be confirmed due to a lack of necessary equipment. But there is hope down the road, and it comes in the form of a single scientific instrument, the James Webb Space Telescope, or JWST. This telescope is here to dive into the depths of our universe. The JWST is no ordinary telescope. It's an engineering wonder, a demonstration of the power of human ingenuity. While other space telescopes have done their jobs competently, the JWST is in its own class. It makes the Hubble Space Telescope seem like a basic speck in the immensity of the universe. The cost of this invaluable marvel is a stunning $10 billion, a number so enormous it's hard to comprehend. This staggering project was the result of collaboration between NASA, the European Space Agency, and the Canadian Space Agency, with contributions from more than 300 universities. Anyway, it's not just about the money, it's about the risks involved. The JWST is venturing into unknown territory, pushing the limits of our understanding and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last over twice its base mission life. Since its launch, the JWST has achieved various amazing accomplishments. It traveled more than 1 million miles to reach its orbit around the Sun, where it will remain forever. During its journey, it successfully deployed its massive 5-layer sun shield and giant primary mirror, both of which had to be folded to fit into the launch vehicle. Now, after NASA has calibrated and aligned the telescope, it is nearly ready for full operation. One of the most fascinating moments came when NASA announced it had captured its first images of starlight. The first picture taken by the telescope was of a star called HD 8446, which resulted in a mosaic of 18 scattered bright spots from the star's light, captured by the 18 mirror segments on the primary mirror. Later, NASA released another stunning image of HD 8446, where 18 unfocused duplicates of the star were combined into a deliberate hexagonal arrangement. Once the observatory adjusts the individual segments of the primary mirror, it will begin the process of stacking the images, merging them into one clear view. Thanks to its cutting-edge technology, the JWST will help researchers study the early stages of the universe, especially the period following the Big Bang. It will help scientists investigate what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized or made electrically charged again by radiation from the first stars. This is only possible with a powerful telescope like the JWST. The telescope will also aid in the discovery of exoplanets, which are difficult to detect due to their interaction with their host stars. The powerful sensors of the JWST will be able to observe these planets in more detail, and in some cases, even image their atmospheres. Understanding the atmospheres of these planets could help researchers predict whether any of them are habitable, as well as studying planet formation. Researchers are studying galaxies to understand how matter is organized on a large scale. This will help us figure out how the universe evolved and how galaxies like the spiral and elliptical galaxies we see today formed from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand this evolution. What Garcia Bernard found will make your hair stand on end. In the central regions of these galaxies, where the black holes dominate, he found a lot of PAHs. Sounds perfect, right? These PAHs, combined with the intense radiation from the black holes, could be the key to understanding star formation in extreme environments. As these molecules glow under the influence of ultraviolet radiation, they create a cosmic signature that scientists can study, shedding light on the hidden processes occurring near black holes. Garcia Bernard's discovery is just one example of how the JWST is opening new windows into the universe, allowing scientists to peer deeper into space than ever before. The telescope's ability to observe distant galaxies, black holes, and other cosmic phenomena in incredible detail is already reshaping our understanding of the universe's origins and its ongoing evolution. With its advanced technology, the JWST has the potential to answer some of the most profound questions of our existence. Is life unique to Earth, or is it possible elsewhere in the universe? Are we truly alone, or could there be other civilizations out there? Could we even be living inside a black hole, as some of the more daring theories suggest? While these questions may seem daunting, the JWST is taking us one step closer to finding the answers. As it continues its mission, it will provide us with a wealth of information that could revolutionize our understanding of the cosmos. We may soon have the tools to explore planets outside our solar system, to study the birth of stars, and even to observe the death of entire galaxies. As we venture deeper into the mysteries of space, one thing is certain. The James Webb Space Telescope is on the frontier of discovery, and its findings will shape the future of science for generations to come. The journey of exploration has only just begun, and the universe is waiting for us to uncover its secrets. Right, well, here's where it gets IR. The radiation close to those very huge dark openings misshaped the pHs, changing them into bigger, electrically impartial variants of themselves. The more modest, electrically charged pHs disappeared into the deep darkness, consumed by the obscurity. Presently, envision being consumed by that murkiness. Yet pause. There's a promise of something better, or perhaps not. The genuine inquiry isn't whether we're alive, however, whether we genuinely exist. Does everything around us exist as a result of the dark opening we dwell in? Everything could be associated inside the hypothesis that perhaps we're not simply living inside a dark opening, but instead inside its event horizon, the limit between the known universe and the obscure. Could it be that everything is part of a dark opening? The James Webb Space Telescope is out there looking for answers to these questions. Stay tuned, and perhaps, quite possibly, it will make us re-examine all that we thought we had some awareness of presence. The truth could be undeniably more turned than we acknowledge. In the entrancing universe of astronomy, few subjects have created as much interest and wonder as dark openings. These cryptic elements, once the stuff of sci-fi, have enthralled the creative imagination of researchers and the public the same. As researchers continue to investigate the secrets of the universe, dark openings stay, quite possibly, of the most baffling peculiarities in astronomy. The idea of a dark opening was first presented in the 18th century by the English natural philosopher John Michio, who estimated that objects with a gravitational force so strong even light couldn't escape them could exist. Anyway, it was only after Albert Einstein's hypothesis of general relativity in 1915 that dark openings were numerically anticipated. These locales in space, where gravity is so extreme that it mutilates space-time itself, have since been the focal point of broad study. Furthermore, every discovery about them seems to lead to significantly more inquiries. One of the most intriguing parts of dark openings is their event horizon, the limit past which nothing, not even light, can escape. The event horizon denotes the point at which the gravitational force becomes overpowering, and this region is frequently depicted as a final turning point. Anything that crosses the event horizon is unavoidably drawn toward the peculiarity at the center of the dark opening. The peculiarity, a place of endless density, is where our current comprehension of physics breaks down. The conditions governing general relativity no longer work under the limit condition inside a dark opening, and the mystery of what occurs inside the peculiarity remains inexplicable. The study of dark openings has uncovered an interesting mystery. While dark openings can swallow matter and light, they also transmit radiation, a peculiarity known as Hawking radiation, predicted by physicist Stephen Hawking in 1974. This radiation is the consequence of quantum effects close to the event horizon. According to quantum theory, particles and antiparticles constantly pop in and out of existence in space near the event horizon. One of these particles might be captured by the dark opening, while the other escapes, diverting energy over time. This process causes the dark opening to lose mass, potentially leading to its eventual dissipation. However, this radiation is incredibly weak, making it almost impossible to detect with current technology, and its effects are negligible for dark openings with masses much larger than the Sun. Curiously, despite their name, dark openings are not void in the conventional sense. While they don't emit light, they interact with their surroundings in strong ways. When matter falls into a dark opening, it forms a hot, glowing accretion disk of gas and dust. As this material spirals in close to the dark opening, it heats up due to the tremendous gravitational forces, emitting radiation across the electromagnetic spectrum, from X-rays to radio waves. The emission cycle allows scientists to indirectly observe dark openings, even though they can't be directly imaged. Sometimes, astronomers have used this radiation to map the environment around dark openings and even measure their size and spin. Additionally, Dark openings can also create powerful jets of energy known as relativistic jets, which can extend for thousands of light years. These jets are believed to be formed by magnetic fields produced by the rotation of the dark opening and the surrounding accretion disk. As charged particles are accelerated along these magnetic field lines, they can be ejected at nearly the speed of light. These jets are often seen in active galactic nuclei, AGN, where supermassive dark openings reside at the center of galaxies. The energy and material expelled from these jets can have a significant effect on the universe, affecting star formation rates and the evolution of the cosmic structure. Recent advancements in technology, particularly with the launch of the James Webb Space Telescope, JWST, are allowing researchers to test the farthest reaches of space and study dark openings in extraordinary detail. The JWST's infrared capabilities allow it to look through vast cosmic dust clouds and observe objects too faint or distant for other telescopes to detect. This will help scientists understand how dark openings grow and evolve over time. Observations of distant galaxies and the supermassive dark openings at their centers will provide critical insights into the growth of these vast giants and their role in shaping the universe. Another intriguing aspect of dark opening research is the possibility that these strange objects could hold the key to understanding the nature of quantum gravity, a theory that seeks to reconcile general relativity and quantum mechanics. At the core of a dark opening, the peculiarity represents a region where both quantum effects and gravitational forces are extreme. Studying dark openings may offer clues as to how to unify these two central theories of physics, which currently operate under different sets of rules. Moreover, the study of dark openings challenges our very understanding of reality. Close to the event horizon, the fabric of space-time is so twisted that time itself is stretched. This effect, known as time dilation, means that time flows more slowly for an observer near the dark opening compared to someone far away. If an astronaut were to fall into a dark opening, they would experience time in a completely different way than someone watching from Earth. This peculiar aspect of dark openings highlights the mind-bending possibilities of space and time, pushing the limits of our understanding of the universe.